Hello friends, welcome to Learner's Planet. Friends, this is our first topic from grade 10, real numbers, right? This is the first chapter from NCERT. So we will be taking various parts of real numbers. We'll be discussing the theory part as well. And we will be taking the problems based on real numbers, right? So before we proceed further, let's discuss what are the different type of numbers. You might have already studied in your junior classes, but we just have a quick recap of various types of numbers, right? Now, the very first type of number is natural numbers, right? You might be knowing that what are natural numbers. The counting numbers, that is 1, 2, 3, 4 till infinity, we call them natural numbers. These are the full numbers, or we can say the whole numbers, right? Because whatever we talk about nature is in always full numbers. See, one paper, one pen, one man, one tree. We never call half tree, half man, half child, half maybe mountain, nothing, right? We always call them in full numbers, right? So that's why we call them natural numbers, because they are in full numbers, right? Now the set of natural numbers is denoted by n, and we can also call them as positive integers, right? Next is whole numbers. Whole numbers are nothing but natural numbers, but one more element is there in the set of natural numbers, that is 0. So if 0 and set of natural numbers clubbed, the set of whole numbers is obtained, right? So natural numbers including 0 are called whole numbers, right? So set of whole numbers is denoted by W. So W is 0, 1, 2 till infinity. So from 1 to infinity, the numbers are called as natural numbers, and apart from natural numbers, we have one more element, 0 over here. So in the set of whole numbers, there is one extra element from natural numbers, right? Next is integers. Negative numbers, that is negative whole numbers, positive whole numbers, as well as zeros. So the three types of numbers are called integers, right? If the numbers are negative, we call them as negative integers. If the numbers are positive, we call them as positive integers, right? And 0 is neither negative nor positive integer, right? So we have this set of integers, these three. Here I can just show you. These are negative integers, these are positive integers, and 0 is neither negative nor positive integer, right? Next is rational numbers. All the numbers which can be represented in the form of p by q, that means the numbers which can be represented in the form of a fraction. Maybe the fraction is in the denominator, it is 1, then also not a problem, the number will still be a rational number, but it should not be 0. That means the denominator should not be 0, right? So we call them as rational number. We can take example, see this 3 by 2, 4 by 5, minus 3 by 2, minus 1, 0, right? All of these are rational numbers, right? Minus 1 can be written as minus 1 by 1, so still it is p by q form. So the denominator should not be 0, so all the numbers are rational numbers, right? So the numbers which can be presented in p by q form, where p and q both of them are integers, right? P and q both of them are integers, right? And denominator should not be 0. So we call them as rational numbers. You might have studied rational numbers in your junior classes also, because the term is introduced in even 6th grade, right? So these are rational numbers. And next is irrational numbers. So the numbers which are not rational are irrational, right? So the numbers which cannot be expressed as p by q form, we call them as irrational numbers, right? So it's p by q form. So in the case of rational number, we discussed that p and q both should be integers, right? But in the case of irrational numbers, the numbers are not integers. Like we can see root 2, 1 plus root 3. These are not integers, right? These are what? Irrational numbers, right? So we cannot represent them as p by q form. So if the numbers cannot be presented in p by q form, we call them as irrational numbers. Or commonly we tell them as surds also, right? So we got the definition of rational number as well as irrational numbers, right? Irrational numbers are the numbers which are not rational, or we cannot represent them as p by q form. Okay. Here we see some examples of irrational number. This 0.01001, this number will be never ending. So if this number is never ending, it will we will not be able to write that number in p by q form. Similarly, this number, that is root 2. If we expand root 2, we'll be getting these digits. So these are non-terminating, non-repeating decimal numbers. So these are example of irrational numbers, right? So the main difference between rational and irrational number is the irrational numbers after decimal, they do not terminate, right? They are never ending, and a certain pattern is not repeated, right? That means a digit is not repeated. Suppose I have a number 3333. It is going unlimited, like that means it is never ending, but number 3 is repeated. So it won't be an irrational number, it will be a rational number. Getting me? So this is what? It's 3 by 9 or 1 by 3. We write 1 by 3 like this, right? So we get the rational number if the digits after decimal are either repeated or limited, right? That means if they are ending, or if they are not ending, then they should repeat. So in these cases, the numbers are neither ending, or that means we can say they are not terminating, and they are not repeating. So these are irrational numbers, right? Now we see about real numbers. All the numbers which we have discussed so far, maybe natural numbers, maybe whole numbers, maybe integers, maybe rational numbers, maybe irrational numbers, all the numbers are real numbers, right? The complete set of rational and irrational number is the set of real numbers, and we denote it by R, right? So real numbers are very, very important, right? See, all the numbers, like maybe if we talk about natural numbers or whole numbers or integers, all these three category of numbers are rational numbers. So broadly there are two categories under real numbers, that is rational and irrational, because natural numbers, whole numbers, integers, all of these are rational numbers. Okay, so broadly we have two categories, rational numbers and irrational numbers under real numbers, right? So all the numbers are real numbers. Okay, so some of the numbers which are not real numbers, but that is out of scope of grade 10, that we will be studying in your grade 11, that these numbers are nothing but imaginary numbers. So the number which is not real, that is imaginary. That means it exists only in the imagination, right? So here we are talking about real numbers. Now the complete set of rational and irrational number is denoted by R and is called real numbers. Now real numbers can be represented as points on a line, and we call it as a real line or number line, right? All the real numbers follow the order property that if there are two distinct real numbers A and B, then either A is less than B or A is greater than B. It's but obvious. Two distinct real numbers are never same. Either one is greater or the other is greater, right? That means either A is greater than B or A is less than B. Okay. Now friends, let's see how do we represent the numbers or real numbers on a number line. Here we see a number line. It's the numbers after 0 are positive numbers, and the number before zeros, or we can say on the left hand side of 0, are negative numbers, right? So here we have positive numbers, here we have negative numbers, right? So whenever we have to represent the real numbers, if the numbers are positive, we represent on the right hand side of the 0, and if the numbers are negative, we represent them on the left hand side of the 0, right? Now the next important thing, whenever we move on this number line, on the positive side, this the number which are on the rightmost side are greater than the number which are on the left hand side, right? That means 2 is greater than 1, 3 is greater than 2, 4 is greater than 3, and so on. So here, from here, if we move this side, the order of the number is increasing order. That means this is the least number and we are going on increasing the numbers. But when we move on the left side of the number line, the numbers are decreasing. That means -1 is the highest negative number, right? If we talk about integer or maybe the whole number, that is negative number, negative integer precisely. So this is the series, then -1, -2, -3, -4. Gradually the sequence will, the numbers will be decreasing. So on the left side of the number line, that means after before 0, or we can say left hand side of 0, the numbers are in decreasing order, and after 0, that means on the right hand side of 0, the numbers are in increasing order, right? So are you clear? Now friends, let's see this chart and have a quick recap of real numbers, then we'll proceed with the other topics. The collection of all the rational and irrational numbers denoted by R is called the set of real numbers. The notation x belongs to R means x is a real number. Now real number is broadly divided in two categories, that is rational numbers and irrational numbers. Now rational numbers, it is broadly divided, further divided into two categories, that is integers and not integers, right? Now integers are three types of integers are there: negative integers, zero, and natural numbers, right? Now non-integers are negative and positive, say -3/2, 3/2, this sort of, right? And irrational numbers are the numbers which are not rational, and they are broadly divided into two categories, that is negative numbers and positive numbers. So this is the whole chart of real numbers, right? Now friends, let's discuss about division principle, right? Now you might have studied the division definitely in your junior classes. Suppose I have a number, maybe 21. If I divide 21 by say 6, what is the remainder? That what I get, right? So if I divide 21 by 6, 6 3s are 18 and 3 is the remainder. So what are the different terminologies over here? This number we call it as divisor. This number we call as quotient. This number we call it as dividend. This number is remainder. Right. Now what are the different conclusions we are getting over here? Just listen to me carefully. See 21, it is dividend, 6, it is divisor, this 3 is quotient, and this 3 is remainder. So if you divide any number by the other number, so if you get the remainder as 0, that means this number is factor of this, right? I take a variable example. Suppose here it is B and here it is A. Now if you divide B by A, and if remainder is 0, I just write it over here. If B is divided by A and remainder is 0, that means A is factor of B, right? Or we can say B is multiple of A, right? Let's take some examples to understand this thing in a better manner. See, suppose I divide 21 by 3, right? Now 21 is multiple of 3. That means 3 into 7 is 21. Right? That means 3 and 7, both of them are factors of 21. 3 and 7 are factors of 21, or 21 is multiple of 3 and 7. Okay, so got the difference between factors and multiples. So in this case, if we divide 21 by 3, the remainder will be 0. Okay, so these are the different terminologies. What are the factors? What are the multiples? Right? The other example, suppose I take maybe 25. If I divide 25 by 3, so it's what I would do. It's 25 divided by 3. 3 8s are 24, and this is 1. Right? So I am getting remainder as non-zero number. That means I am getting remainder as 1. That means 25 is not a multiple of 3. Right? 25 is not multiple of 3, or 3 is not a factor of 25. Okay, because we are getting the remainder as a non-zero number. So if we get the remainder as 0, the number over here will be multiple of this number, and if we do not get the remainder 0, then the number over here, it's not multiple of this number or the number over here, right? Now friends, let's be clear about the other terms of division also. Now suppose I divide maybe 35, I divide by 6, right? Now 6 5s are 30, and I get the remainder as 5, right? So this is what divisor, this is what dividend, this is quotient, and this is remainder, right? Now suppose I have maybe 45, and I divide it by 7. So 7 6 are 42, and this is 3, right? So this is divisor, this is dividend, this is quotient, and this is remainder, right? So there exists a relationship among these 4 numbers. Now what's that relationship? Is dividend is equal to divisor into quotient plus remainder, right? Now let's take these two cases and verify this formula, right? Dividend over here in this case is 35 is equal to divisor into quotient, that means this into this, plus remainder, that means this. So we get 35, right? So this formula is verified. Further, we take one more example, that is this example. Here the dividend is 45. Divisor into quotient, that means this into this, that is 6 into 7, plus remainder, that means this. So 6 7s are 42, plus 3 45, right? So we verify this formula. So the dividend is equal to divisor into quotient plus remainder. This formula is an important one, right? Just by heart it or learn it carefully. Okay. Now friends, let's discuss Euclid's division lemma. Now first of all, let's understand what is lemma. Lemma is a proven statement used for proving another statements, right? So that means a statement or a theory which is already proved, and we are using that particular statement and theory to prove the another theory or statements, right? Now what Euclid's division lemma is, given that a positive integer a and b, there exist unique integers q and r satisfying a is equal to bq plus r, right? Where r is between 0 to b, and q and r are quotient and the remainder respectively, right? So it's the same thing which I have explained you just now, right? That means dividend is equal to quotient into divisor plus remainder, right? So this is the same thing, right? Now what's algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. That means what is the first step, second step, third step, fourth step, fifth step, right? So if you need to solve a problem, what will be the different steps to solve that particular problem? We call that as an algorithm, right? So see, we do not have to mug up the terminologies. Ultimately, we have to learn the concept, right? So let's do it. Now, friends, let's discuss Euclid's division algorithm. It's, as the name suggests, it has something to do with the divisibility, or we can say division of integers, right? It says that any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r and that is smaller than b. It's we know that, but if we write it in a language, this will be the language, right? That means, suppose I take any example, maybe you divide 8 by 3, right? So if you divide 8 by 3, so what is the remainder that you will be getting? 3 2s are 6, so the remainder is 2, right? So this remainder will be either 0 or it will be less than this number, that is to say. Okay, that is what the Euclid's division algorithm. Now what's that? I just repeat it once again. If you divide an integer by another integer, so the remainder obtained will be less than this number. Okay, it's obviously okay. So this result has many applications related to the divisibility properties of integers, and we can compute the highest common factors of two given positive integers by Euclid's division lemma, right? So what is the process of HCF? It is steps, or we can say algorithms are written over here. I just read the entire steps before you, and will do the problems. After that it will be clear to you, right? So to obtain the HCF of two positive integers, say c and d, where c is greater than d, right? We have to follow the steps, right? So definitely dividend is equal to quotient into divisor plus remainder, right? That's we already know. Now if r is equal to 0, that means if remainder is 0, that means what? This suppose I just take that example also, it's 6 3. So if remainder is 0, that means this number is multiple of this number, right? So if r is 0, that means if this number is 0, that means the remainder is 0. That means the HCF of these two numbers, that is 3 and 6, the HCF of these two numbers will be this only, the smaller number only, right? So you got my point? If remainder is 0, the smaller number, we have two numbers 3 and 6. If we divide 6 by 3, that means the bigger number is divided by the smaller number and we get the remainder as 0. That means the HCF of these two numbers is the smaller number, right? Now, if we do not get the remainder as 0, then we further have to take one more step till we get the remainder as 0. Now, what will be the next step? Suppose in the first step, maybe the remainder is not 0. I just take maybe this example, right? So here I'm not getting the remainder as 0. So here, after this step, what I'll be doing? I'll be dividing this number, that was the divisor over here. Now I will divide this number by the remainder, right? Now let's see what happens. Now 2 1s are 2 and still the remainder is 1. So still the remainder is not 0. That means 2 is not factor of 3. That means HCF of these two numbers is nothing but 1, right? That means no number other than 1 is common between the two, right? So we keep on dividing. Now suppose next step, if we take 2 1 2s are 2 and it's 0. So the HCF of 2 and 3 is 1. I just take a few more examples so to elaborate. Now suppose I have to find out the HCF of say 42 and 63. Now how would I do that? By Euclid's division method. Just see it carefully. The bigger number should be divided by the smaller number, right? So 42 as divisor and 63 as dividend. So 42 1, Now 3 minus 2 is 1 and this is 2, right? So in the first step we are not getting the remainder as 0. That means HCF of 42 and 63 is not 42, right? So for this is the first step. After that, if we are not getting the remainder 0, what will be the second step? That is, now this number we will use as dividend, right? So it's 42, right? Now we will divide 42 by this remainder, that is 21. So 21 2s are 42. Now we are getting the remainder as 0, right? So what is happening over here? If we get the remainder as 0, that means HCF of these two numbers is this, right? So HCF of these two numbers will also be this. So HCF of 42 and 63 is 21, right? HCF of 42 and 63 is 21, right? So keep on dividing till you get a 0, right? I'll take more examples. Now let's find out the HCF of 52 and 117. Now we have to divide the bigger number by the smaller number. So 117 and 52. 52 2s are 104. So we got 13. Now that means the remainder is not 0. That means HCF of 117 and 52 is not 52. We have to go for one more step. So now I would divide 52 by this remainder, right? So 52 and now I will use as dividend. Now 13, if I divide 52 by 13, I get 13 4s are 52 and remainder is 0. So now I got the remainder as 0. That means HCF of 13 and 52 is 13. So HCF of 52 and 117 will be 13, right? Okay, because we got 0 in the second step. Okay, so it's clear to you? Friends, will be taking more problems of finding out of HCF of two numbers in our next session, and we'll be taking some more theorems on real numbers. So do revise this session before coming to the next session. Bye bye.